Hi guys, welcome to the next episode of the Rusty Beauties Restorations, and today we are back on the 1970 TR6 and we continue with our endeavors here in attempt to get the car ready to start it. So in the previous episode we dealt with the oil, we primed the oil system. The engine was rebuilt about 5-6 years ago by me in another shop, and then I started it and I drove it, just yard drove it, and then we decided to change the camshaft. There were issues with that camshaft. It was some racing, like high tune, whatever camshaft, so we put a standard camshaft in it, but after that we never started the engine. So yesterday I primed the oil system properly and we cranked the engine for the first time after that rebuild, or after we installed the new camshaft, and now we continue setting it up so we can start it. And we're gonna have to break in that camshaft because it's never been run with it, so we want to make sure that everything is in a good shape and it can sustain running for half an hour or so. That's where we are. Very quickly, what we still need to do before we start the engine is we need to fix the carburetor linkage because it's flimsy. We need to supply fuel to the fuel pump. We don't have the line from the gas tank connected, so we're gonna do just a jug. We need to finish the fuel lines here, connect them to the carburetors. We need to install the distributor driving gear properly. We took it out last time to prime the system, so now we're gonna have to install it, install the distributor, set the ignition timing. I want to check the cam timing because, like I said before, I made multiple times the same mistake with timing because of my degree wheel, how it was set. It was tricking me and I kept falling into the same trap multiple times. So now I want to make sure that I didn't make that mistake on this cam. And then I think that's it. We need to fill up the coolant system and attempt to start it. So I don't know if that's gonna be in this video or next video, but we're gonna continue with prepping for that. So without further ado, let's get crack-a-lacking.
When are we going for a drive?
Yeah, tomorrow's Drive Your Triumph Day, so maybe we can go for a drive tomorrow.
Supposed to be plus 10.
Perfect. I don't have a drivable Triumph here. The only one that was here you took apart.
True.
I was planning to drive it for Drive My Triumph Day. Alright, so these carburetors, these are DGV 3236 Webers. They look in a pretty good shape, but the linkage somehow is not very responsive. So David just brought me these collets here, because if you see here, there's a piece of hose that they installed before as a stop, so the shaft doesn't move back and forth. But David, Mr. Chef Tash, donated this to the project. So these are collets that go at the end of the shaft like this, and they even fit. Wow. Just need to loosen the set screw. There's a set screw inside here. And we're gonna fix the shaft so it doesn't move back and forth, but still somehow the linkage feels really stiff and it doesn't come back. So we want to make sure that it moves nice and easy and it returns nice and easy. So what I'm gonna do to begin with is I'm gonna break the whole system into separate components. We're gonna loosen all the levers here and make sure that each separate component moves nice and smooth on its own, and then we're gonna put them together as one unit. Okay, so this carb on its own returns pretty well. It doesn't need a push from the rest of the linkage. This one doesn't return. Okay. Let me show you. Yeah, it stays, you see? You have to shake it a little and then it comes all the way. So probably a drop of WD-40 here. That's one thing. But I think the main resistance comes from the original Triumph linkage here. You see, it doesn't come back. We have a spring here that is not really great, but also here this plate is pretty loose, like this. Isn't it supposed to have shims here that serve like as bearings? Look, it doesn't come back. Oh my god. Disconnect this as well from here. You know what? I'm gonna remove the whole shaft. This on its own actually returns all the way. That is good, but I don't like that this is so shaky and twisty. I don't like that. Let's remove this bolt. This bolt has a shoulder that doesn't allow it to pinch this plate in the middle, but I think it needs to have some like truss bearings here on the side. Otherwise it creates too much friction between this bracket and the actual plate. So let's see what's there, and we might make something if we have to. Okay, so you see here what's going on. The shoulder has a little bit of play inside this plate. I don't think it's that critical as long as we have enough shims, because we can't make it perfect. I mean, I can always machine this down and make a brass bushing that is fitting here exact, but I don't think we should go overkill. What I'm thinking is if we add a spacer like this that is flush with the shoulder, so then when we go through this plate and tighten it, it just gives it enough room to spin, but it doesn't pinch it. However, to make a spacer like that is a little bit tricky. That's why I'm thinking instead of making the spacer thinner, I think we should remove a little bit from here on the screw, just make the shoulder a little bit longer so it is flush with this spacer, and that's it. Okay, so that actually works pretty well now. There's still a little bit of play. It's actually a lot of bit of play, but it is between the bolt, between the shoulder of the bolt and this plate. So another option is to drill this hole on the plate bigger and make a bushing for there. But can I justify the time? I don't think so. Because if it is on my own car and I can spend all the time I want, it's one thing, but when it is on somebody else's car, I think that's how far we should go with this without killing John financially, you know? Okay, so that goes underneath. What about the lathe? Oh, haven't I showed you my new lathe? Oh, I haven't showed you my little lathe. Okay, let me show you. So that baby over there, you've seen me using it multiple times. I outgrew it. I mean, my shop outgrew it, let's say. I mean, it's been a great help. I have multiple accessories for it. Like, it's done lots of jobs that I didn't expect that lathe of this size would do, but it's underpowered. I can't do many of the operations very well. I constantly have to adjust the gibs here, and when I have to do something bigger, even though it fits on the chuck, it doesn't have the power to do it, especially after my board burned. So this board somehow burnt out, like literally. let the smoke out. So I don't know what was wrong with it, but they don't sell just the board. They sell you this whole thing, which is, it has totally different board, and configurations of buttons and everything is different, but it fits. I put it on and it works, controls my speeds and all that. But still, the lathe is really underpowered, especially for threads and stuff like that, doesn't really work. So I was keeping my eyes open for a cheap lathe of a little bit bigger size than mine. So this one came up on Marketplace and I bought it, and I already made some improvements to it. It had the tool post. This was the original tool post and I removed it. I have to bag it and put it away for safekeeping. And I put this quick replace tool post, whatever it is called. Originally it comes with 4-inch chuck, but the seller also gave me this 6-inch 3-jaw, and there's a 6-inch 4-jaw chuck that he gave me with the lathe, so that's great. The problem is it has a little bit too much run out because of this homemade adapter plate here. It's not extreme, but it is still a lot of run out, so one day we're gonna have to take care of that. But anyway, it is good enough for little jobs. It's much better than my little lathe, but we still need to do some improvements on it. So that's it. It is 9x19 Grizzly G4000, I believe, and it's in a pretty good shape. The ways don't have any marks on them or stuff. So anyway, I'm happy with it. Hopefully it's gonna help us in our future endeavors here in the Rusty Beauty's garage. Alright, so installed the linkage. Nothing is connected, but all three components now are moving on their own. I mean, here, even with the old spring, so Chef Tash is gonna bring me a new spring for here. He's gonna donate this to the project as well, as these two collets. Anyway, this now comes back on its own, no problem. What's quick is the spring, this spring here. So anyway, this component on its own works fantastic. This here always worked well. I mean, never had issues with that. So like I explained, this movement here is only on one of the throttle plates, and then for the, I don't know all the terminology, but for the high revs we have a second throttle plate that starts opening after this one is opened 1/3 of the way. So this lever here, or this tooth on this shaft, hits the other lever, and then it starts opening also the other shaft here. So both shafts come back fully closed, no problem. This one was a little bit of an issue. I mean, the second shaft was coming back no problem, but the first one was getting stuck right here. So if we press all the way down, now you see the second one closes, and now the first one starts closing as well. But sometimes this second one was staying like that, right here, and it needed a push. But I sprayed WD-40 here, I sprayed WD-40 on this end of the shaft, right there, and I played with it for a while, and now it is perfect. So now we know that all three components work on their own. None of them relies on the other two to push it back. That's how it should be, because sometimes I've seen that on other cars, on SUs or on Strombergs, where the throttle plate on one carburetor doesn't return, and people start adding springs here and everywhere to push back the linkage. But the linkage is not supposed to return the throttle plate or the throttle shaft. The throttle shaft should be able to return itself on its own, and this spring here is for the linkage to return on its own. So the linkage doesn't rely on this spring here to return it back. So now that we know that all three components here return on their own, now we can hook them up together, and maybe we should just hook up one first, make sure that everything still works. But if something doesn't work when we connect one carburetor, we will know that the problem is somewhere here, and once we fix all that, then we can add the second one and do the same thing. Okay, the other thing that we want to make sure is that the shaft is spinning freely inside these two, like, what are they called, ball joints? Because they are adjustable. So if I take it out of one, you can see the bow inside and adjust for the angles. But the problem is that if the shaft is bent, for example, that bow inside is going to need to move constantly back and forth to compensate for the bend in the shaft. So that's why we're making sure that when it goes through both, it spins freely without any issues. Now that we know that as well, we can add the levers here. One thing that I noticed was that this lever here has a very extreme angle. Let me connect it and I'm gonna show you. This is what I mean. This is pretty extreme angle. I'd like this to be a little bit higher, so we have a more closer to a square angle here. If something is this much bent and you push on both ends, it's harder to bend it. But if it is already bent this much and you push on both ends, it's much easier to bend it. You know what I mean? So I'm afraid that because the angle is too small, it might bind a little bit. So I'm going to extend fully those threads as high as possible. And something else I noticed here, look at this right here. The lever is actually spinning without the bolt spinning, and that's not how it's supposed to be. This bow inside is supposed to spin. This needs to be stationary on the lever. Let me take it out again. And it has lots of resistance here, of course, because this is super tight. Okay, I removed it from the linkage at the bottom. I loosened this side and I removed it. This side is still super tight though, you see? But if we loosen here, it's gonna start moving, I'm sure. There you go. But I don't want to just loosen it because it's obviously super dirty inside. So I'm gonna take it apart and I'm gonna lubricate it, and then we're gonna tighten it again. And then we're gonna adjust it so when we put it on the bow, that's bent and the plunger won't come out, but so we're gonna adjust it so the bow can still move inside, but it doesn't create too much tension. But let me take it out completely off here and see if that's true. Oh yeah, that's a true. So let me see if I can punch this out. Came out, the spring came out. So we're gonna clean this properly, we're gonna wash it, we're gonna put some white lithium grease in, and we're gonna assemble it again. And we're gonna do the same here. Okay, let me go wash all of that and I'll bring you back. Okay, it's all cleaned up. Even inside here, I reached with this brush and it's nice and clean everywhere. Now the only problem is I can't find my lithium grease. That's one of the few things in the shop that always gets misplaced. So we're gonna use regular grease anyway. So let's assemble these first. We have to put them, let me see. Okay, so the configuration is 90 degrees from each other. This goes towards the manifold and this goes towards the carb. So that's how we're gonna put them. So now we're gonna take a Q-tip with grease and we're gonna lubricate the walls inside. That's it. We don't need a lot of grease. We just need the parts to be able to slide back and forth without too much troubles. So first we have a spring, then a plunger. The plunger has this step here, that's for the spring, and then on the other side it has a spherical shape, so it accepts the bow. We're gonna lubricate that as well, like that. So this can go inside. Again, we're gonna lubricate the bow as well. No, that was the opposite. That was on this side, wasn't it? Yep. So I have to turn it around. Okay, that's better. So now The bow goes like this. The top one was with the flat screwdriver, and here we're gonna put some thread lock. Okay. So that's a little bit too tight, I believe. That's now pretty good. It still stays where we leave it, but it is pretty loose. Okay, so now these holes here are for a split pin or cotter pin, whatever you want to call it. So let me see if I have this size. Okay, that's way too small, the hole. My cotter pin won't work, but 1/2 of it is gonna work. So what we're gonna do is we're gonna use just a little bit of it, like that, and we're gonna bend it. Okay, I think it's more than okay. So we're gonna do the same for the bottom. We're gonna assemble it, and I'm not gonna hold you for the second one. I'm gonna install it on the linkage and we will see how it's gonna move. So the bottom is installed as well. Nice and snug, but not tight. So it allows it to move up and down, and look at that now. It moves no problem here. Okay. This side we don't need to do much about because this is just lubrication. It's plastic there as well. There's no springs or anything, and it's pretty loose. You just need to tighten this nut wherever we want it to be. This one is both sides plastic, so it just needs lubrication inside. So I'm gonna assemble them now. I'm gonna put the collets in both ends to hold the shaft, and then we're gonna look at it together and see if everything returns as it should. Okay, so I put the collets here and here, made sure that the shaft still spins. Put a little bit of lubrication inside because this spins inside like in a bushing, so we need lubrication. Then now we are testing it. See, I'm testing it after every stage to make sure that there's no resistance. We're gonna tighten this one now. We're gonna test with one carb, and then we're gonna install the other one and test the other carb as well. Okay, we hooked up this one as well, and it returns no problem, but there's a problem that occurs when we push all the way. So watch that vertical lever there that we just rebuilt, how the bottom goes past this bolt and it locks there. Bang, you see? Now it's stayed. I can push it back and it comes back, but it stays. And the other problem is, which is also related to this problem, now our throttle inside, let me turn on the light. Our second throttle inside for the high revs is not open at all. We have a lot more movement here that we are not utilizing. And this movement, if I push here, it goes, you see, it opens it. Now it opens it all the way. The problem is that our lever down there doesn't go high enough. The ratio between this lever and this lever needs to be much smaller. We want this one to travel less and this one to travel more. So the only option that we have is to move this pin closer. So the closer to the shaft it is, the more angle it's gonna give on the shaft, right? But it is already short, you know? That angle is gonna become super extreme. Okay, you know what? Let me try and move it to the other hole, even though it is too short now. But let's see how it's gonna work, and if it works well, then we're gonna have to find or make another threaded rod for here that's much longer, because this is way too short. There we go. I moved it, but look at how extreme the angle is now. But if I push here now, look at that. Hold on. Now, of course, it's going to require much more force. So let me use my right hand, because now we have a shorter lever there, right? But it opens the throttle all the way now. Okay, again, I need the light. Like that. So it's closed now, and it opens all the way, no problem. So all we need to do is extend this rod so we can still put it on the same hole, but the lever should be pretty much horizontal. So I disconnected them, so now this is loose, and I put this lever pretty much where I want it to be, and when we put it under the last hole here, where we want this to go, that's about, I should say, 3/4 of an inch maybe. Yeah, 3/4 of an inch longer threaded rod we need for there. So this is the rod that came out, and I checked the threads and they are 1/4 inch, 28. And I was looking around to find a bar that I can make threaded rod out of, and guess what I found? A bent push rod from a TR6. Guess what size that is? It's exactly 1/4 inch diameter, so that's what we can use. So that's why I never throw away old parts, because they always come handy and can be repurposed. Old bearings, I have old gears and stuff. Like, I keep everything. Maybe I keep too much, but I keep stuff that comes handy after. Okay, so that's much longer now, and this is the angle that it sits in. I'm pretty happy with it. So now you see this lever goes all the way, the throttle opens all the way, and then everything returns all the way. Now we're gonna make sure that this is the same length, which it is not, but we're gonna adjust it to be the same length as this one, so we can have the same angle on both sides here, and we're gonna install this lever as well. Okay, everything is attached now. Everything works as it should, I believe, but I'm gonna test it also with my pedal. So I put the pedal in such position that when the throttles are fully open, I hit the stop on the back of the pedal. You know, there is a stop on the bulkhead, but everything is returning all the way. So I'm happy with that. Okay, so you see how a little bit here, a little bit there, but everything affects your operation of your throttles. So before you start adding springs and all that, I suggest that you check all the components separately and see where the tight spot is when your throttle is not returning all the way. Anyway, so now I'm gonna run the carburetor. So now I'm just gonna run the throttle. So now I'm just gonna run the, what are they called? The choke cables. Oh my god, okay, so now I'm just gonna run the throttle. So now I'm gonna run the choke cables. We're gonna install them as well and make sure that they operate properly. Let's see how the chokes operate the levers themselves. Okay. Oh, this one closes better than this one. Look at this. I have an issue here. Okay, I see. Let me show you another problem. Oh my god. Alright, I'm not a carburetor specialist, and especially not Weber specialist, because these are pretty sophisticated for me. But you see how this is the choke lever, and it pushes this lever up, and this lever pushes the chokes closed. You see both of them. But this here at the bottom has a spring, so even when it's closed all the way, I believe the vacuum, it can still open the choke a little bit, and that is thanks to this spring here. So this one works well, but this one, there's some resistance here. You see, this one, the spring starts compressing before they're fully closed. So here, there's something that is making the chokes really tight. You see, the spring is doing a good job, but at this point, the tension of this shaft becomes too much, and that just closes the spring here instead of closing the chokes. So, why? Oh, I can see why. Because, there you go. Oh my God, I'm becoming a specialist. So you see this mark on the wall here? That's where this plate starts binding, and that doesn't allow it to go up. So we need to loosen these screws and adjust the plate. Problem with these screws is that they're not reusable, supposedly. Now it closed. There you go. So did you hear that click when I pulled this side up? Now it is how it should be. However, aren't they supposed to return on their own, or they need to be pushed with the cable? Looks like the cable pushes them back. Okay, we will see when we attach the cable if the cable is going to be able to push them back or not. Yeah, I don't see a spring. Oh yeah, there is a spring on this. So you know what? I'm going to lubricate here a little bit as well behind. So hopefully they're going to start coming back on their own. I don't want to rely on the cable to push them back, but looks like the spring is tired. So I lubricated here the springs at the back, and there's I guess like a bushing here where this lever rotates, so it comes back from this position, but if you push it all the way, it doesn't. It just needs a smidge so it comes back, but it's not. And I even lubricated here the hinging points of the shaft, and it just needs a little bit. So I'm hoping that the choke cables are gonna help with that. This is the same. Needs very little. Anyway, I need to find out which hole they come out through. Is it this one? I don't know. I'm gonna look on that, my favorite diagram. That's interesting. It is this hole, but look what it says, choke and heater control cable. So 3 cables are coming through the same hole. Okay, unfortunately we have a problem with the chokes. So I run all 3 cables from here. This is for the heater, and this one, and these are the 2 for the chokes. Now, first of all, we're missing the screws that hold the cable here, but that's not a big deal. I figured it's an M4 screw. I don't know why metric, but this cable is like about to snap here at the end, and it's been taped here before, so obviously it has an issue here as well. And I tried, like I put it in place, but it doesn't return. You have to manually retract, manually close the choke. So I'm actually gonna do it again. I only found 1 screw, M4, and it's a stupid screw. I'm gonna buy nice screws for here and here, M4. So look how easy it is to open the choke once it's closed. See, I'm just holding it here with 2 fingers and it comes back. But still, even though it's so easy, the push of the cable is not enough. Look, it works this way. You can see I'm pushing now, and look, the other cable moves, this one doesn't. And it's not like it doesn't require just a little bit, it requires a lot, like to be pulled a lot. So there's tension inside the cable, and I know I even have a tool to spray WD-40 inside the cable, but I don't think this is a good option for this one. So we're gonna buy a new cable. We're gonna keep this one for now, so we can operate the chokes kind of manually, but we're gonna need another one. So this I'm gonna put as well here, and I'm gonna find the screw for here as well. You know what, I'm gonna move this screw. Yeah, let me move this screw here and see if this is gonna work properly. Okay, this one closes and opens. You see, if the choke cable is in a good shape, it's gonna work well. The problem is though, this one is not. Anyway, this one we're gonna operate manually for now, when we're for the first start, and we're gonna deal with it later. Okay, so that's about the chokes. Well, let's not waste any more time. I'm gonna hook this up as well, since we're here, and then I'm gonna deal with the fuel lines. Okay, installed the fuel line as well, but I don't like this. It has fittings here, but I don't see a better way of doing it. So many things. I thought that I was almost gonna start the car today, and I'm dealing with these carbs for I don't know how long. We still have to deal with the distributor on the other side. Oh my god. Took this out, but look, it's spinning. So definitely that's gonna leak, and these are plumbing fittings that I don't think are a good idea for there, even though we have this type of connection on the fuel pump, right, with the olive inside, but here somebody even puts plumbing tape, which you shouldn't need since you're using the olives. The olives are what seals, and the nut here is just to push the olive in. So we have to find a different solution for that. My god, why is everything so expensive? Unbelievable. Okay, here we are in my shed, and I have this engine that has been donated to me, and it has the same downdraft Webers on it, but it has a simple three-way splitter here, so maybe we can take this one out. But also, that's my TR6, you see. Oh my god, my poor baby. I don't know when I'm gonna get to it. That's David's TR4, the one that he's rebuilding the engine on. And here I have another TR6 engine with transmission. Again, donated to me by the same guy, Chris. And it has this on it. I think we're gonna take this out. I don't know though. Are these lines a little bit smaller? I don't know. Anyways, I'm gonna take both out, and we're gonna see what we're gonna use. Alright, so turns out that this is part of this whole thing that probably got snapped, and they just cut the three-way splitter and used hoses. So there's nothing wrong with that. We can use it, but I wanted the original style one, so I wanted to clean this up and use it, but it was bent, so I tried to straighten it, and this happened. So I turned it into this. Anyway, now we have two of these. Anyway, okay, I'm gonna clean this up, and I'm gonna make the connection with hoses again. Okay, this is how we're gonna do it. I just don't have 1/4-inch hoses. All these hoses that were used everywhere were 5/16. I have no idea why, because this line is 1/4-inch, this one is 1/4-inch, and I'm gonna take this out now to see. Probably this is 5/16, you know. Let me check. Yeah, this is 5/16. So I don't know what we can do. All right, so tomorrow, because now it's the end of the day, I'm not going out for parts. But tomorrow I'm gonna stop at the store and I'm gonna buy 1/4 inch hose. I'm also gonna buy 2 screws for here, M4 we said, right? With a hex head. Unfortunately I can't buy cable, I'm gonna have to order that. Alright, it's the next day and I bought 1/4 inch fuel line. I had a little hard time to push it onto the carbs, but it fit perfectly and now everything else fits well. Here, remember, we had a fuel filter and I bought a new one to replace it, but we're not gonna put it here. We're gonna put it down there where the pump is, before the pump, because that's where it's supposed to be. Where did that fall? I hope not inside the carbs. The little cup. Oh, it's down there. Okay. Make sure that it's not inside the carbs. Yeah, but for now, actually, what we're gonna do, I decided that I'm not gonna use the mechanical fuel pump for the first start, because I opened it and I made sure that it was rebuilt and all that, but you know what? I don't want to remove all the variables from the first start. I want to make sure that we have a steady supply of fuel, so I'm gonna use an electric fuel pump that I have. So just temporarily, we're gonna put this filter here. So this is the direction. We're gonna unplug the hose from here. We're gonna put the fuel filter here, and on the other side, we're gonna connect my electric fuel pump just for the first start. Then when we're ready, we're gonna connect this back here and the fuel filter is gonna go down there. I also got screws for here. They are a little bit longer than what I would like to, but maybe we can shorten them later. But once the air cleaner box is on, you see the screw is hidden underneath, so it's fine. Here, the metal is not rubbing on the sheet metal. The hose is rubbing. I don't know how to keep it down. I don't want to run zip ties or anything. So that's it. I'm gonna have to check what hose here need to be plugged, because I believe these are vacuum lines here. So we need to plug these unless we connect them to the distributor, but that's gonna happen later. For now, we're gonna plug all the hose, including this one, most importantly. And I think fuel-wise, we are ready. Now, I started already working on the distributor, but I'm gonna leave that for the next video. This linkage problem took more time than I expected, so thank you guys for watching one more time. Thanks for commenting and subscribing and sharing. Thanks for supporting me on Patreon and PayPal. It is really, really appreciated. That gives me the opportunity to spend more time on the computer, not only in the garage, and edit these videos and upload them for you to watch. I'm really happy that many of you find them interesting and they continue to support me in order to continue doing them. So stay tuned for the next episode, in which we're gonna check the distributor, install the electronic ignition, we're gonna check the cam timing and check the ignition timing, and then hopefully start it. So we will see how that's gonna end. I'm sure it's gonna be an interesting video, so stay tuned. I'll see you then. Bye.